Welcome back. Today, we are going completely under the hood of SAP Plant Maintenance. We aren't just looking at transaction codes today, we are looking at the blueprint. We are going to explore how a business strategy transforms into a functional SAP system. We will cover planning models, the system landscape, the key consultant roles, and the digital twin of your operations master data. Let's dive in. Before a single piece of software is configured, a business must make a critical decision about its maintenance philosophy. This choice is usually driven by three things: geography, cost, and control. There are two primary models you need to understand. First, we have centralized planning. Imagine a massive industrial complex, like the JSW steel plant in Vijayanagar. Here, you have a main hub surrounded by smaller satellite plants, perhaps a tar plant or a cement plant nearby. Because they are geographically close, it makes sense to have one central planning plant that manages the maintenance for all those satellite locations. It centralizes expertise and reduces costs. However, what happens when your plants are spread across the world? That brings us to the decentralized model. If JSW has a plant in Mumbai, another in Dubai, and one in Italy, you cannot efficiently plan repairs from a central hub. It would be too slow and expensive to send technicians back and forth. In this case, every plant acts as its own planning plant, operating self-sufficiently. Once the strategy is set, we move to the SAP system landscape. You never make changes directly in the live system. Instead, we use a controlled assembly line of servers. It starts in development. This is the workshop. Consultants build configurations and write code here. Next, it moves to QAS, quality assurance. This is the proving ground where we test everything to ensure it doesn't break the system. Finally, it reaches PRD, production. This is the live environment where business users do their actual daily work. But how do changes move between these servers? We use a transport request or TR. Think of a TR as a truck loaded with your configuration changes. Here is a great analogy from the steel industry. Moving data from one client to another inside the development server is like moving steel coils inside the plant. You don't need special permission. However, moving that TR from development to quality is like shipping steel out of the plant to a customer. You need an out-gate pass. In SAP terms, the TR must be released to lock the data and ensure it's safe for transit. Who actually builds and maintains this system? It takes a village. You have the functional consultant, who understands the business process and configures the system. You have the technical consultant, or ABAper, who writes custom code when standard SAP can't do the job. And sometimes, you have a techno-functional consultant, a hybrid expert who can do both. These consultants guide a requirement through a specific life cycle. It starts with planning and analysis to understand what the business needs. Then design and development, where the solution is architected and built in the dev server. Then comes testing. This is crucial. We perform unit testing to see if the configuration works alone, integration testing, SIT, to ensure it works with finance and materials management, and finally user acceptance testing, UAT, where the client gives the final sign-off. Only then do we train the users and go live with support. Now, let's talk about data. In SAP, data is organized into three distinct tiers. At the bottom, the foundation, we have organizational data. This is the framework of your company codes, planning plans. It is created once and rarely changes. In the middle, we have master data. This describes the objects of your business, your equipment, work centers, and bills of materials. It is semi-static, it changes, but not daily. At the top, we have transactional data. These are the daily records, work orders, notifications. You cannot create these without the first two layers. Let's zoom in on master data. Think of this as the digital twin of your physical factory. To manage a pump in real life, SAP needs a digital reflection of it. Here are the essential terms you must know. Work center, this represents who does the work, your mechanical or electrical teams. Bill of material, BOM, this is the list of spare parts needed for that specific equipment. Task list, this is a template of steps. Instead of typing instructions every time, you pull in a standard task list. Maintenance strategy, this defines the when, scheduling rules like every 3 months or every 500 hours. Class and characteristics, these allow you to store technical details like a motor's RPM or voltage. So, how does this all come together? Let's look at the anatomy of a work order. Imagine a pump fails. A failure is reported for a specific piece of equipment, that's master data, located at a specific plant, that's org data. A work order is created to manage the repair. The system automatically pulls in the work center to assign the team, the task list to tell them what steps to take, and the BOM to tell them what parts to use. The work order is the conductor of the orchestra, bringing all your static data to life. Finally, why do we do all this? For the data. In the old days, technicians wrote repairs in a physical logbook. The handwriting was illegible, and the data was impossible to analyze. In SAP, we use something called a catalog profile. Instead of typing free text, the technician selects standardized codes for the object part, the damage, and the cause. Because the data is structured, we can generate powerful reports. We can instantly see that 45% of our failures are due to bearing damage. This moves us from simply fixing things to intelligently preventing failures. To recap, we moved from the strategic choice of centralization through the 3-server landscape, understood the consultant roles, and built a foundation of master data to drive efficient work orders. Mastering these basics is the first step to becoming an SAP plant maintenance expert. If you found this breakdown helpful, please hit like and subscribe for more deep dives into SAP modules.